Hello and welcome to another video. We'll go through another problem of the merge interval classification. And this problem basically is an extension of the previous problem we worked on, which was merge intervals. So ideally we had two intervals and we wanted to merge the overlapping intervals. In this problem we are provided so we already have a list of non-overlapping intervals sorted by their start time. Insert the given interval at the correct position and merge all necessary intervals to produce a list that has only mutually exclusive intervals. So essentially the merge interval algorithm remains the same, what we went through, and because here we do not have to sort the array, our runtime will essentially be O of n because we want to go through all the elements once, and we'll have insert, which will also potentially be O of n. So we'll have O of 2 of n, and we know how big O works. So essentially our runtime for the implementation will be O of n. So the way I'm thinking about solving this problem at this point is first identify the index. So we do have a sorted list, and we have the first element of the interval itself. We can identify we can identify the index at which we want to insert this new interval. Once we have identified the index, we can go ahead, insert the interval, and then go through our previous algorithm as usual and merge the intervals which we can. Okay, so let's just go through the examples, have a dry run, and see how we can get a more concrete understanding of the problem itself. So we have intervals given here. We have 4 and 6. We see that given the first or the start element of the index, it should be inserted at the first index. Once we be inserted here, we see that there is an overlap with 5 and 7 here, and if we merge both the extremes, it will be 4 and 7. And the rest we do not see overlap with anything else, and there shouldn't be. So essentially I'm thinking if there is a way of optimizing it, but given that this insert is only based on the first element, we cannot be sure. Yeah, so for example, if this was say 20, essentially we could have merged 8, 12 within this range itself as well. So it isn't like we only have to look at the indexes around the insert. Okay, so let's try to implement a simple solution, and from there we can see if there is further optimization. Again, in this case, we go ahead and insert here, and we saw the merge, and this is exclusive. Okay, we see the merge now also happening of the final one. Again, based on this will be the first insertion. We see an overlap with this one, so okay, we keep the extremes. So the idea is clear. What we are working on is clear. I just hope, okay, in this case, instead of having the intervals class, we are being provided the list, which again is fine, just a bit difficult to keep a track of. Okay, so first will be insert. I was kind of thinking of doing insert separately in a function, but the naming is terrible, so we we have named this function as insert, but let's do it. Merge, insert and merge. Insert merge, so we have an insert function which takes the intervals and the new interval, and returns basically the updated intervals with the merged interval in it, and here we have merge. So and we know that this is sorted, so let's get the interval after the insert. So at this point, what I want to do is I want to loop through all the elements in the interval. And I want to see, or I want to identify where the first element of the interval is greater than the first element. Okay, so I want to have two elements of the interval at once, essentially. So one will be okay, so I only want start, so I can start at intervals 0 and the 0th element, which will be start, and I essentially want to say for I in range len of intervals, and I have the new interval, which is intervals I, but I want a start, which is 0. Okay, so interval start. So essentially what I want to do at this point, do we have any conditions about the correct position and merge all necessary intervals to produce? We have a list of non-overlapping, but can it be that the first element of the new interval is similar to the first element of, say, some other element in the list? Have we seen that before in the examples? We have not, actually. We have not. Okay. Interesting. So, like, the most basic thing is if new interval 0 is, say, more than equals to start, and new interval 0 is less than or equal to interval start, then I would say I want to insert at index I. So essentially at this point what I want to do is I want to say Okay, let's keep a track of this one. Insert index, and let's keep it to something that is not okay, let's keep it to 0 because we will have an insert. This is what I'm expecting. So insert index would be I in this case. And what I want to do in the end is I want to do intervals dot insert. I want to define, I want to insert at the insert index provided here, and I want to insert the new interval. This is perfectly possible that my indexing is not correct. So let's just do a dry run on one of the examples. Okay, let me take it from here. A more complicated one on the insert. Okay, so our start is simply the 0th element and 1. Start index, insert index is 0 at this point. Yeah, but this can be a bit dangerous. Okay, let's address it, or maybe let's do minus of len intervals plus 1. So this index would not be present either way. Minus 1. Okay. Let's just do it like this. Okay, so we have 1 as the start. We have, okay, here we want to start from 1. Okay, a good catch. So we extract the 5 here. If the new interval 0, which is 4, is more than start, which is 1, and the new interval 0, which is again 4, is less than or equal to interval start, which is 5, which is the case, then my insert index is basically 1, and this is where I actually want to insert it, which is correct. Okay, so let's see how the intervals look after the merge. I'm expecting this to be here. Let me print I as well. Print insert index. Okay, this is slow. So basically here, right? I don't get it. see what's going on. New interval dot 0 4 is more than equal to start, which is 1, and new interval dot 0 4 is less than equals to interval start, which is 5. Okay, this is a problem. That's actually not a problem. One for here, actually insert went fine. But in 2 cases, I don't think the insert went as expected. Okay. This is also where we want to break. Probably. So in the final one, we are receiving a negative infinity, which is this case. Let's see why this is the case. So we essentially have a 2, 3, 5, 7. Okay, we are not checking. Okay, so we are not checking if the insertion needs to happen at the start or the end of the list, right? So we can essentially do if interval 0 is less than or equal to, I would say less than, intervals 0, 0, then insert equals to 0. We also have a condition if this is the other way round. The final element. In that case, insert index is simply the len of intervals -1. Okay, cool. This will go here. Okay, seems like both of the cases have been addressed. Okay, we'll have a look at in case we are missing something here, or if in case we are missing any edge cases here at a later stage. Let's jump right into our implementation of the merge itself. Again, it will remain very similar to what we had. So the start would simply be intervals 0, 0, and would simply be intervals 0, 1, should be 0 for I in the range 1 to len of intervals. Again, we spoke about the merge. The merge simply meant if the end is greater than, so okay, we want an interval here, start equals to intervals I 0, interval end I1, and essentially if end is more than the interval start, and this again is the overlapping condition. In this case, we want to update the end to the max of either end or interval end. Else we want to update the merged append the start and an end in case there are no overlaps, and we also want to update the start to the current start and end to the current end. And we want to go ahead and append the final element in the merge as well. So let me be more careful about the structure. So this would give us actually this would give us the final merge implementation which we are looking for. Let's do a sanity check quick. So we have everything right. Overlapping condition, if the end is more than the interval start, this means that we do have an overlap. In that case, we want to update the end. In case we do not have overlaps, we want to update the start, append the start and the end in the merge. and we want to update the start and the end to the current start and the end for the intervals, and we want to append the final interval as well. This would return the merge. So let's see if this works. Okay, I don't really know what the solution is. At least I don't remember. So 1, 3, 4, 7, 8, 12 should be the output of the first one. 1, 3, 4, 12 should be out of the second one. 1, 4, 5, 7. Okay, so seems like this is working. Let's have a look at the space and time complexity of the problem. As we are iterating through all the intervals only once, the time complexity above is O of n, where n is the total number of intervals. Space complexity of the above algorithm will be O of n, as we need to return a list containing all the merged intervals. So I hope you found the approach and the implementation interesting. Please leave comments if you think something was not clear. And again, as mentioned, we'll go through all these questions one by one, and also through all the other classification itself. So stay tuned if this interests you, and I'll see you next time.